Okay, so I know mine has color and yours does not, but we can still kind of look at what's going on here. So what information can we get from a graph? Let G be a twice differentiable function. One of these graphs is the graph of G, one is the graph of G prime, and one of the graphs is G double prime. So the things that we need to talk about when we look at these graphs is what do these graphs represent? So G is our original function. So this is going to be the thing that's being described by these other two graphs. G of x is going to be describing when we are increasing versus decreasing. And G double prime is going to describe when we are concave up or down. As we look through these different things, we need to look at what those things are telling us. So what I might look at here is looking at this first graph. I am increasing until about here. So if I look in here, 1, 2, 3, so around -4 to -3, I am increasing. So if I were to look at this function, I would want, if this was f of x, my derivative needs to be above the x-axis in between -4 and back. So if I'm looking here, -4 is about here, that place. This is above the x-axis. I'm decreasing afterwards until about here, which is not quite 1, almost, which would be about here. So I'm below the x-axis in here, and then I go above. So what this tells me, just looking at those two graphs, these match up enough that if this is f of x, then this has to be f prime of x. So whatever one the first one is, the second one, it has to be the derivative of it. Now, when we bring in this third graph, this means either the first one is f, the second one's f prime, or the first one is actually f prime and the second one is f double prime. So we need to look at what's going on. So if we look at this graph here, we are decreasing first. So right before -5, I am decreasing, which means I should be below the x-axis. In between -5 and -4-ish, I am now in between -5 and about here. So a little after, or a little before -2, a little after -1. We are looking at that positive value, and then after that we are negative. If I look at what was our original f of x, we are under the x-axis for that first little bit. We are above the x-axis for a little chunk here up to that -1, and then we're below the f-axis for the rest of it. So what this tells me is if this is y, this has to be y prime. So looking at what we know here, that means number 3 has to be g of x, number 1 has to be g prime, and number 2 has to be g double prime. So what we really want to do is analyze what we have going on here. If we look a little bit further into this first, or into what we think is g of x, if we look, we have concave up until about here. This is going to be where our point of inflection is, and then we have concave down. Once we get over here, we can't really tell what's going on because it could be going like this, or it could be continuing on like this, and we just don't know. So we're going to focus on that first piece here. So concave up until about here, which would be making sense for this double second derivative. If it's above the x-axis and it's the second derivative, that means it's going to be concave up. And then it's concave down for a really long time before we get to this piece over here, which is when we don't know what's going on anymore because the graph isn't big enough to tell us. Okay, we're going to look at the second one. A big giveaway is what kind of function a graph is, so we'll talk about that in a second. So if we look at these functions, we want to kind of compare. So just like what we did earlier, I'm going to start with one of our graphs and then compare it to the graph next to it. So in this graph, we have that it's decreasing to begin with to about here. Then it's increasing until about the y-axis, and then it's decreasing to increasing. So we are below, above, below, and above. If I look at that here, we're below the x-axis, then we're above the x-axis, so we're good. But we don't dip back below the x-axis until after x equals 1. So this isn't going to quite work for us. So let's look at the other one. We are below the x-axis. We are above for a little bit. We change at what looks like 0, 0, and then we are below again, and we become above again. So what this tells me is, because I was looking at when we were increasing and decreasing, if this is f of x, that means this has to be f prime. So now we need to look at this middle graph. So I can look at increasing or decreasing, or I can look at concavity. So let's look at concavity to kind of have an idea of what's going on here. So if we are looking at this, this is concave down, which means our second derivative graph would need to be negative. Then we change to concave up, then back to concave down, and we're back to concave up. So our second derivative would be negative all the way up to about here. And then between these, we're going to be positive. All the way to about here, we're going to be negative again, and then we're going to change over to positive again. So we're changing back and forth between positive and negative. If I look at this first one, we start out positive, and I need our graph to start out negative. If I look at that third one, it starts out negative. Because I was looking at concavity, that means if this is y, this is y double prime. So if I kind of combine these two ideas together, that means our second one has to be f of x. Our first one has to be f prime of x, because it's going to be in between our two functions here. And then our last one has to be f double prime of x. This is one of those things that may take a little bit to kind of understand what to look for, things like that. And it's one of those ones where sometimes we'll see all of those graphs stacked on top of each other, and it's just a little bit overwhelming to look at. And it just takes a little practice to like dissect what's going on. So I said that there is an easier way to think about this. If we think about this as derivatives, this right here looks like an x to the fourth graph. This looks like an x cubed graph. And this looks like another odd graph. We'll even say x to the fifth. If I look at these and I'm thinking about what a derivative does, it makes sense that this would be x to the fifth. The derivative would give us x to the fourth. Derivative would give us x cubed. So I can kind of tell if I can identify what graphs we have. Sometimes we can't always do that. If we look at the one that we had above, this looks like an odd function. This looks like it could be an even function, but this also looks like an odd function. We don't have enough information in our graph to make that big decision like we do here.